Good evening, everyone.
Good evening, ma'am.
Good evening. How are you all? Good evening. All good?
Yeah.
Ma'am, I have a doubt. Can I ask? It is a
Okay.
technical doubt.
Technical doubt.
Yes.
What is
Ma'am,
it?
actually, in my week 3 extra activity,
Hmm.
I was graded 92, but my peers three of them grade me 95, but they all accepted that there is no issue.
Hmm.
So I should be getting full marks, ma'am.
Okay. So maybe something is there. Okay. So the thing is, that is the extra activity. The scores have been updated, right? Or is it not?
No, ma'am, the score hasn't updated.
Has not been updated, right? So just wait for 2 days more. Let's see, because the final will be given by the instructors, right?
No, no, the final
Ah,
I can see the score in the dashboard
yeah,
right
you
now.
can see that. That is fine. Okay. But again, it will get updated after 2, 3 days. So that is what I'm asking. Like if it has been
Okay, so
updated or
it will
not.
update again after 2 days.
Yeah, after a few days. I think so it should be updated. So let's see. And if it's not that case, then maybe some issue is there or like in the peer review or
Ma'am,
your
but
project or something.
I should be able to know the issue so that I can correct it. But I am not
Okay.
able.
Hmm. Okay, just wait for a few days. Let's see if the
Okay.
scores is getting updated or it's the same. Then we will see. Okay.
And can you
Hmm.
give me your email ID if the score did not get updated, I can contact.
In the discourse, you can share it. Okay.
Okay.
Yeah. Just tag the instructors or the TAs, and then you can ask. Okay.
Hello, ma'am.
Okay, ma'am.
Yes.
Ma'am, in week 8 graded assignment, we can't means I can't able to see the option number means last question activity.
Now also,
Sir, ma'am, in
just a
the week
second. Just a
Yes,
second.
ma'am.
So, Soumya,
no,
just
no,
a
I
second.
am
Let me
also
just.
doing the same
Uh,
thing.
you're also because in mine it is
Yes,
showing.
in the mail we are informed that
Uh,
the last question in grade assignment week for week 8 will not
See, in the
be.
last question that we okay, the options are not there. That I also
So,
accept.
ma'am, I
There
should
is some
attempt the
issue.
question or just keep it empty.
Sorry.
I should fill something there or keep it empty.
The options are not there. Maybe I think uh,
No, it
it
was
has
informed that it will not be
be
considered
evaluated.
for
Yeah, you don't
grading.
have to fill that then. If it's not being evaluated, then don't fill it. Okay?
Okay, sir.
Ma'am,
Ah,
hello.
yes.
So should we leave the blank or should we means
Yeah, just leave that whole question. Just leave that whole question because the options are not there, na, so you can't fill it. So just leave that last question. Okay?
okay? But I
Hmm.
checked and I compare week 7 activity and week 8 activity both is same. But in
Both are
8,
same. There is some
ah,
technical issue. Yeah,
yeah.
technical glitch is there. That's why we said just leave that question.
Okay, so should I clear and again resubmit or should I leave as it is?
Hmm.
Anyway, it is not going to evaluate like
It
that.
is not going to be evaluated. So if you fill it or not, it's like it's going to be you don't know.
Discard.
Ah,
Okay.
okay.
Okay, thank you, ma'am.
Shall we? Okay. Shall we start now? Let's complete it. Huh? Okay. Okay. So in week 7 and week 8, what we are going to learn, the first thing is what all are there in week 7? Anyone? Few topics, if you remember.
Empirical distributions.
Empirical distribution. Okay, that is not a main thing. So I'm just going to tell
Ma'am,
you like a rough
sample
summary.
means
What are
sample
there?
variance and
huh,
Week law.
the main thing.
and weak law of large numbers.
Yeah. So we are not going that deep.
Just
We are
sample
just
variance
going.
with IIDs.
So sample mean, sample variance, WLLM. Okay, and
Computation.
these are there in week 7, right? Then in week 8 we have movement generating function, and second thing is central limit theorem. Okay, so there are 5 topics that we have to cover. Okay, now first of all, what does sample mean? Anyone?
X bar.
Yeah, it is denoted by x bar. So basically, x bar is basically the summation of all the xi's divided by capital
Yes.
small n, right? Now these xi's are what? Like let's suppose my x1, x2 till xn
IIDs.
are IID. And what are these IID? IID is,
Independent and identical distribution.
what do you mean by independent and identical distributed?
They follow the same distribution and they are independent of occurrence of each other.
Yeah. So basically, it should
One,
be, if I'm taking a sample, that sample should be identically distributed in the sense, like, see, this x1, x2, xn, they are all coming from one variable, which is x, one distribution, which is x, right? So they are identical. And the sample should be independent. That means my x1 should be independent of x2, x2 should be independent of like that. Okay. So this is what we call IID samples, which is independent and identically distributed. Fine.
yes, ma'am. Yeah.
Okay. Now, in the sample mean, we calculate the expected value and variance, right? So what is my expected value? Expected value of a sample mean is
Mu.
Mu.
mu,
Distribution mean.
which is equal to the distribution mean. Correct. Okay. Then we have the variance of a sample mean, and variance of a sample mean is basically
Sigma square by
Sigma
n.
square
Sigma
by n.
square.
sigma square by n.
N.
Okay. Now, if my n tends to infinity, then my variance will tends to
Shrink to 0.
Zero.
will tends to 0. Correct. Now comes my sample variance. How is my sample variance denoted? It is denoted by h square, and the formula is
Xi summation of xi minus x bar divided by n minus 1.
x square upon n minus 1. Okay. So just remember that my sample variance is being divided by n minus 1. If you are talking about the population variance, we are just dividing this by capital N.
N.
Okay. Now, in the similar way, expectation of s square is basically
Sigma square.
it is sigma square. That means my if I calculate the expected
Distribution
value for
variance.
sample variance, it will be equal to the distribution variance. Okay. So we got to know that my expected value of a sample mean is equal to the distribution mean, and my expected value of a sample variance is equal to the distribution variance. Fine.
Yes, ma'am.
Okay.
Ma'am, can you repeat your statement again?
This last statement.
Yes, ma'am.
Yeah. So last statement, they are stating that my expected value of a sample mean. So this is my sample mean. So expected value of a sample mean is equal to my distribution mean. Okay. And expected value of a sample variance is equal to my distribution variance. Fine.
Okay, ma'am.
Yeah.
Yes,
Okay.
ma'am. Fine.
So you just have to remember this thing: the variance of a sample mean, then the formula of a sample variance, and this formula. Okay. Now comes what else?
Excuse me, ma'am, but the expected value, that mu, right? Distribution mean. So it is mu1 plus mu2 plus mu till mu n by n, right?
Which one? Which one?
The expected value of the down equation which you wrote.
This one, na?
Yeah. So
Huh.
that mu is equal to mu1 plus mu2 to mu n by n, right?
No, no, no. See, okay. So my x1, x2 till xn are my IID. from X, correct? And my
Yeah.
expectation of X is given to be mu. This is the population mean, correct? If I need to calculate the expectation of a sample mean, it would be what? Expectation of summation of xi divided by n. Yes?
Yeah.
Okay. So 1 by n will be taken out. So this will be summation of expectation of xi.
Okay.
This can be written as 1 by n expectation of x1 plus expectation of x2 till n. Yes. And
Mm-hmm.
all of these xi's are IID samples, right? So my expectation for each of them will be mu only.
Okay.
Yeah. Till n times my mu. So this is basically what? N mu divided by n, which is mu. So that's why my expectation of a sample mean is equal to my population mean. Got the point?
Okay. Okay. Got it. Got it. Got it.
Okay. Yeah. The similar way, you can just calculate this expectation of a sample variance of a sample mean as well, which is sigma square by n with the same thing. Okay. So the thing is, you told that mu1, mu2, they are not, they are the, mu is actually my population mean, which is the mean of x, not the sample mean. Okay.
Okay, ma'am. Thank you.
Yeah.
The distributions variance, right, ma'am? Sigma square by n.
1 second, what?
Sigma square by n is the
Hmm.
variance of the distribution or the sample dr. Sigma square
So
by
this sigma square is my population variance.
okay.
Okay. In the similar way, right? So variance in place of E, just put V. Okay, so this will be 1 by n square, variance of xi. So all of the, and variance of x is basically what? Sigma square. So this n times we will add. So sigma square that we are using is actually my population, which is the mean variance of x. Okay.
Okay, ma'am.
Now comes the scaling and summing. In the sense, let's suppose I have x1, x2, x in IID from S, X, and S is the sum of all the samples. Okay. Now, if I have to calculate the expectation of S, it will be basically what? Expectation of x1 plus expectation of, that means the individual, the addition, the sum of individual expectation, right?
Yes, ma'am.
Yes. Yes. Okay. Now, similarly, if I have to calculate the uh, variances, variance of S will be
Variance of equal and
Variance
variance.
of x1 plus variance of
x1 this. And we are saying that as they are IID, that's why we can use this. We can say that my variance of a summation of all the samples will be equal to their individual summation of variances. Okay, because they are independent and identical. Good. Okay. Now let's suppose my S is A1 x1. Okay, let's take A1. AX2, similarly AXN. Then my expectation of S will be
a times ex1 plus a times ex2.
uh,
We are using the same coefficient for all the
for all the terms. So
exercise.
we can take A common, then the expectation of N into expectation of X. Okay. Similarly, let's suppose my S is A1 x1 plus A2 x2 plus AN xn. Then my variance of S will be
A1 square.
A1 square variance of x1 plus A2 square variance of x2 and so on. Correct? So this
Yes,
is
ma'am.
how hmm, So this is how I calculate if I have been given an IID sample, if I have to calculate the expectation of sum of all these samples or the variance of these samples. Okay, is this thing clear?
Yes, ma'am.
Okay. Then comes weak law of large numbers. Okay. So what is weak law of large number? Basically, we are just trying to find out the distance between the x bar and mu, correct? So what is my equation? What is my equation? Probability that mod of x bar minus mu is greater than some constant. This probability is less than equal to sigma square divided by n delta square. Yes.
Yes, ma'am.
So this is my weak law of large number. Is it okay for everyone? This is my probability that mod of x bar minus mu is greater than delta, some constant value, and this probability will be less than equal to sigma square by n
Ma'am,
delta. Hmm.
ma'am, could you please explain this formula, like what it gives to us, or the uh, please express it?
Okay.
Yeah.
If you do you remember Chebyshev's inequality?
Yes, ma'am.
Chebyshev's inequality, you know that. It's actually what probability of mod of x minus mu greater than k sigma less than equal to 1 by k square, correct?
Yes, ma'am. Yes, ma'am.
This is what Chebyshev's inequality. Okay. Can you tell me what is Chebyshev's inequality, like what it states?
It gives the upper bound basically.
Upper bound for what? So basically what we are, so okay, can you just define it what this depicts? It is actually telling me how my like my sample value differs from a mean, like what is the difference between the x and mu with oh, just a second. Okay, how much standard deviation my mean differs from my sample value. That is my Chebyshev's inequality, right?
Okay, ma'am.
By what multiple of the standard deviation?
Huh. So similar case, we are just trying to find out like my sample mean, how much, what is the difference between my sample mean and my population mean? If I have to calculate, so what the probability that my sample mean differs from my population mean is greater than some constant value. This is delta. This is some constant value. That probability will be less than sigma square by n delta square. Fine.
Yes, ma'am.
Okay. This formula is basically from the Chebyshev's inequality. In place of x, just put it x bar, and in place of k sigma, just put it delta and everything, and you will get this formula. Okay.
Okay, means we will get the formula in the exam.
Formula, which formula?
This one.
This one.
Yes, ma'am.
This, I don't think so. They will be giving you. You have to remember this. I said.
Okay.
In
Okay.
the Chebyshev's inequality, it was in week 4, right?
Yes, ma'am. Week 4.
So in quiz 1, they give you Chebyshev's inequality?
Ma'am, it is given in the
Yes, ma'am.
previous
It
question
is
paper.
It was
given.
given. If it is given, then this will be also given. But for your safety, like just remember this, now. This is just in place of delta, in place of k sigma, this is delta. In place of x, we have x bar. That's it. Okay. Okay. Now can you
Yes,
guys
ma'am.
tell me uh, what is this? Which bound they are saying? It is telling me
Variance of
bound,
population.
bound.
Upper bound.
It is telling me upper bound. Okay. Now can you tell me the formula of lower bound? It is basically probability of x bar minus mu
Less than delta.
hmm,
1
greater
minus
than
sigma
sigma
square upon
square
n
and
delta square.
delta square. Now this thing, this value is basically what?
Lower bound.
This is my lower bound. So till now, nobody has no confusion in upper bound and lower bound, right?
Yes, ma'am. Clear.
It's clear, right? In Chebyshev's also we used to find out the upper bound and the lower bound. Similar in the similar way, we are finding out the upper bound and lower bound in the weak law of large number. Okay, so weak law of large number, just remember that it is basically for the sample mean. Okay, and Chebyshev is basically we are just calculating for this some value, random value. Okay, so in the question in the exam they won't be giving you to find the probability according to WLL. No, they will be saying you with the help of Chebyshev's inequality find the probability. Just remember that. Okay. I have everyone has done previous year questions, so you must have got the point. Correct?
Yes, ma'am.
Yeah. Okay. So this was all in week 7. Am I leaving anything? I don't think so. Sample variance, sample mean. Yeah. These are some main points to remember in week 7. The main thing is this weak law of large number. Then this thing, the scaling and summing. This point is you should remember, and the formulas. Expectation of x bar, expectation of s square, and the variance of x bar. Okay. These are some of the main things that you have to remember. Is week 7 okay?
Yes, ma'am.
Okay.
Yes,
Let's
Yes,
move
ma'am.
on to week 8. In week 8, we are trying to find out MGF. What is MGF?
Moment generating function.
Movement generating function, and it is denoted by M of x
Mx of
lambda,
delta lambda.
lambda, which is basically expectation of e raised to the power lambda x, right?
Yes, ma'am.
Okay. Now, uh, now this is e raised to the power lambda x. Okay. In general, my e raised to the power expectation of x is basically what? Summation of x into probability of x. Yes.
Yes, ma'am.
Okay. So now in the similar way, my mx lambda will be equal to what? I can just write it down as 1 plus expectation of okay. This will be summation of e raised to the power lambda x into my you can say the
probability of lambda.
function or the probability of x. This is my mx lambda, right? And this case is
Yes, ma'am.
basically when we have discrete case. Okay. Now we will integrate e raised to the power lambda x into the probability or the function when I have a continuous case. Correct? Yes or no?
Yes, ma'am.
Yes.
Okay.
Yes, ma'am.
Now one more thing. My e raised to the power lambda x is actually, if I just open it. So basically this is equal to 1 plus lambda x plus lambda square s x squared divided by factorial 2 plus so on it will go on, right? So if I find out the expectation of e raised to the power lambda x, this will be what? Expectation of 1 plus lambda x plus lambda square x square by factorial 2 plus so on, right? So this will be what? 1 plus lambda expectation of x plus lambda square by factorial 2 expectation of x square and so on, correct? So this is basically what? My MGF, the other form of MGF. Yes or no? Yes.
Yes, ma'am.
Yes,
And
ma'am.
what you written in denominator?
Factorial 2. Oh, okay, this is, I'll just change the sign then. This is factorial 2. Now fine.
Yes, ma'am.
Okay. So this form you should remember it. Okay, this is important. Now in this, my expectation of x is basically what? My first movement. Yes or no? My expectation of x square is basically my second movement. Similarly, my expectation of x3 is third movement and so on. Okay. So the main thing is you have to remember this. What is my mx? Then this form. Fine.
Ma'am, what is the movement, please? You can you
Hmm?
define a
Sorry.
little bit? No, what's a movement here? Could you please define it a little bit?
Movement is just my like the first movement is basically my mean. First movement. Movement is actually they are talking about the like okay. So my expectation of x is basically what? My mean only, right? So what is my mean? Mean is like my average value. Like I am just depicting my whole data with some constant value, right? Some
Yes,
with
ma'am.
one value. So that is what my movement is. So we are just basically depicting the whole data with one movement, with one value. That is my movement. So expectation of x is basically my first movement. Expectation of x square is basically my second movement, and so on. Okay.
I can solve
Yes,
one
ma'am.
with
Yeah, we will be solving. I'm just going to see. I have questions that we will be solving some questions. So I am just clearing all the theory part and then we will come back to the question parts. Okay, right?
yes, ma'am.
Yes, ma'am.
Okay.
Yes.
Okay. Let's take an example. Uh, okay. My x is following. No, my x is having numbers. Suppose what -1, 0, 2. Okay, and the probabilities are 1/2, 1/4, and 1/4. Okay. Now, can you tell me what is my MGF here? It is basically what? Summation of, these are my discrete. This is my discrete, right? So it will be summation of my all the values of xi into the probabilities,
Ma'am, it is
है ना?
e
हाँ.
to the power
So
minus
sorry,
1.
x is basically e raised to the power lambda. So this will be what? E raised to the power lambda into what
E
is
to
my
the power
first x
minus
value?
1.
-1 into probability, which is 1/2, plus e raised to the power lambda into 0 into 1/4, plus e raised to the power lambda into 2 into 1/4. So I can write this as e raised to the power minus lambda into 1/2 plus 1/4 plus e raised to the power 2 lambda into 1/4. Okay, now so let's suppose in the exam, I have been given only this thing. Okay, now you need to tell me the PMF, or yeah, the PMF of x. So how will you do it?
Lambda's coefficients will be the random
Ha,
variables
correct.
and probabilities will be the other.
Ha, correct. So all the coefficients of my lambda will be my x value, and all the probabilities which are being multiplied by e is basically my probabilities. Just remember that. Okay, is it fine?
Yes, ma'am.
Yes, ma'am.
So this was all about MG. One more thing. Let's suppose I am having two samples, x1 and x2, which are IID following x, and let y be equal to x1 plus x2. Okay. Now if I need to find out the MGF of y, it will be what?
Expectation of e raised to lambda
So
x1
is
plus
ma'am, it
MGF
is
of x
MGF
and
of x square.
x1.
What?
MGF of x square. MGF of, yes, x lambda square. Yes, this
Lambda
one.
square.
No, whole square actually.
Correct. So how we found this? It is basically what? Expectation of e raised to the power lambda x1 plus x2. Correct? In place of y, I just put
Yes.
x1 plus x2. So this will be expectation of e raised to the power lambda x1 plus lambda x2. Now I can write this as expectation of e raised to the power lambda x1 into e raised to the power lambda x2. Now this will be expectation of e raised to the power lambda x1 into expectation of e raised to the power lambda x2. And this is basically my MGF of x1, and this is my MGF of x, x2. Right? And all these are my IID samples. So I can write this as mx lambda plus mx lambda, which is basically my mx lambda whole square. Correct? This thing is clear?
Yes, ma'am.
Yes? Okay. So, another thing? Huh, that's it. So this was all in MG. Now comes the central limit theorem.
Ma'am,
Hmm.
just a slight doubt. Ma'am, you have
Huh.
written e raised to expectation of e raised to power lambda x1 plus into e raised to power lambda x2 as the product of both expectations. This is because they are independent.
Huh.
Okay, ma'am.
See, na, my X1 and X2 are independent IID samples. Na?
Yes, ma'am. Got it.
And you remember that in expectation, if my two variables x1 and x2 are independent, then only I can say my expectation of x1 into expectation of x2 is basically the individual product of x1 and x2, correct? So that is the
Yes,
same.
ma'am. Yes.
Fine. Okay. Uh, okay, one more thing is there, which is the, okay, centralized. What is centralized variable? Let's suppose if my x is some variable, okay. Now, I need to find out the centralized variable of x. It is basically what?
Difference from the mean.
Correct. Difference from expectation of x. So this is my centralized version of x. Right? You have to remember this thing. What do you mean by centralized variable or centralized version of x or something like that? Okay.
Ma'am,
Hmm.
ma'am, we are calling this centralized. Is there anything that
If you remember the centralized thing, what is centralized? In centralized variable is a variable in which my expectation, my mean is equal to 0.
0. Yes,
Yes.
ma'am.
You remember this thing?
Mean
So
0.
let's suppose
yes?
mean is 0. So let's suppose my y is x minus expectation of x. Then my expectation of y is coming out to be 0 only. Yes.
Okay.
Yes, ma'am.
So this is my centralized version of x. So let's suppose if I say my let's suppose my x is having some value. X is having- Okay, let's take this example only. My values are -1, 0, 2, 1 by 2, 1 by 4, and 1 by 4. Who there? Can you just mute yourself? From there. Can you just mute yourself? Okay. Now, what is the expected value of this? -1 into 1 by 2 plus 0 into 1 by 4 plus 2 into 1 by 4. Can you calculate this value and tell me what is the expected value?
It is already mean 0.
0.
0 only.
Ma'am,
Just take
because
one minute.
moment
-1,
generating
0, 2.
functions can only be applied to centralized
Okay.
variables.
Take one more example. Okay. Let's take 0, 1. Okay. And this is 1 by 2. This is 1 by 2. What is the expected value here?
1 by 2.
1 by 2.
1 by 2 only. Okay. Now you need to calculate. So now this is my one variable. Okay. Now you need to calculate the MJ for y, which is my centralized version of x. Okay. So basically my y will be what? X minus expectation of x. Yes.
Yes, ma'am.
Yes.
Okay. So my y values will be what? What are the values that my y can take? It will take
-1 by 2 and 1 by 2.
-1 by 2 and 1 by 2. Right. And the probabilities will be same only 1 by 2, 1 by 2. So now this MGF will be the summation of this, which is e raised to the power
-1 by 2 lambda.
into 1 by 2, lambda by 2 into 1 by 2. Okay.
Yes, ma'am.
Yes, ma'am.
Okay. So this was about the centralized version. Okay. Now that was it. Then we have the central limit theorem. Okay. So what is the central limit theorem?
Means, ma'am, if we apply this centralization for this thing, so there will be two equally divided thing, and there will be. Can you please explain?
Okay. So central limit theorem is basically what we are doing. We are just approximating the probability to a normal distribution having 0, comma 1 as the parameters. That is, mean is my 0 and my variance is 1. That is my CLT. So let's suppose I'm having x1, x2, xn IID samples from x. Okay. And let y be my sum of the samples. Okay. Now, if I have to approximate it, okay, if I have to convert into a normal, standard normal variable, what I will be doing? I would be subtracting this variable by its expectation and dividing it by the standard deviation of y, correct?
Yes, ma'am.
Yes or no?
Yes, ma'am.
Okay.
Yes.
Ah. So now, what is my expectation of y here?
And mu,
It will be nu, and my variance of y,
sigma square,
sigma square,
N sigma square.
n sigma square. Okay. Now, this thing is basically what we just denoted by z. So, z is basically y minus nu divided by n sigma square, which is following a normal distribution with 0, comma 1 as the parameters, right? So, basically, what we are saying that if I have to convert a random variable or I have to approximate it to a normal distribution, what we will be doing? We will be subtracting that variable with the expectation and dividing it by the standard deviation. This is my CLP. Okay,
ma'am, why necessarily have to be the sum of xi's?
we can take anything. Let's suppose I'm taking my y is actually my x1 plus x2 till xn divided by n. Then, if I have to convert this,
Ma'am,
it will be
ma'am, variance of y sigma square by n or n into sigma square?
n into sigma square. See, variance of y is basically what? Variance of y x1 plus x2 till xn. Their IID samples, so it will be equal to the individual variances. So this will be what? Sigma square plus sigma square till n times. So this will be n into sigma square.
See, ma'am, in that we have to take 1 by n square out, right?
Uh,
Variance of.
Where?
That we will do when we are taking mean, right? Oh, okay.
Okay. In here it will
Yes,
be we will
ma'am.
be doing it. So basically, okay. So what is y? Y is basically my x bar, right? So this is I can write this as x bar minus expectation of x bar divided by standard deviation of x bar. What is my expectation of x bar? It is mu. Yes or no?
Yes, ma'am.
Yes, ma'am.
And the variance of x bar is sigma square by n. So this is
Yes,
x
ma'am.
bar minus mu divided by sigma by under root n. So this will be following a normal distribution with 0, comma 1, right?
Ma'am, this is true for every for any I.
Fine. The main thing is the CLT is we are just approximating that distribution to a normal distribution. That is, if we have to convert into a normal distribution, we have to do this thing. That is CLT. Okay, central limit theorem. Fine.
Okay,
So
ma'am.
this was all in week 7 and week 8. All the theory part and everything, the main thing. Okay, so in this week 8, the main thing is you have to remember this thing. You have to remember this thing, and you just have to remember what is my expectation of x, what is my expectation of x square. Okay, then you have to remember that if I have been given the MGF, from that how can I write the PMF of x, like that. Then You need to know what is my centralized version of X, how to write it centralized version, and then need to find out the MJF and the TLJ. Okay,
Ma'am, what about gamma and beta distribution?
that is not come.
It's not there.
Sorry,
Is it there? Is it not there?
it's not there.
But will it be there for n term?
And and no, it will be like gamma will be there and beta will be there, but uh, like in the coming weeks in 9, 10, 11, 12, there are beta gamma distribution is there. We will study there as well. So you don't need to
Okay.
worry about it.
Okay.
Ma'am,
Thank you.
I have a doubt in activity
Yeah, just a
8.4.
second. Yeah, just a second. I'll just complete this thing and come back to that. Okay.
Ma'am,
Let's
but
just
don't we
complete.
have, ma'am, ma'am, but we
Huh?
don't we have this gamma and beta distribution questions in week 8?
But we don't have. Huh?
Ma'am, the questions on gamma distributions and beta
Huh.
distributions are there in week 8 also, no? So are they not included in the
Yeah, there.
syllabus for quiz
I'm
2?
just telling you with the point of view for this exam, for this question. It's not coming in question.
So the questions will not come on those topics.
Huh.
Okay.
The topics that I have told you right now, na, these are the things that are coming, like the main thing. These are the main things that are coming. And the topics that I have not taught here, it's not there in this class. That's it. That beta, gamma, and everything, it's not there. Okay, then the proportion thing, one topic in each, then the proportion thing is there, na? That is also not coming. Okay,
Okay, ma'am.
Ma'am, there is another formula in the lecture. The moment generating function equals to e to the power lambda square sigma square by 2. Is it important?
that is for the normal. Not,
Yes.
that is for the normal when we have 0 comma sigma square. Like that is the MJF of a normal distribution. E raised to the power lambda sigma square by 2. It is following a
And
normal 0
lambda
comma
square.
sorry, lambda square sigma square by 2. Okay, this is the MJF of a normal distribution. It means 0 and leading sigma square. Okay,
Ma'am, so that's it for NGF, only these two formulas?
huh. Huh.
Okay, thank you.
Okay, let's do some question. Okay. A random sample of size 64 is collected from. You guys have pen and paper with you, right?
Yes, ma'am.
Okay. So you need to solve this question and let me know the answer. Okay. So the question is, a random sample of size 64 is collected from a normal population with mean mu and weight sigma square. Suppose the expected value and the variance of the sample mean is 40 and 0.16. Find the value of mu plus 5 sigma.
Ma'am, 56.
56. Any other answers?
Yes, ma'am.
Any other answer?
Ma'am, please wait a minute.
56, ma'am.
Okay, okay. Two answers by count 56. 71 answer is 71, 80. Any other?
Ma'am, 56 as well.
56. Okay. Okay. Should I solve it? Shall we solve? Or should I wait for more people to do it? Any one of you doing it?
Ma'am, you can solve.
Okay. So we have a random sample of size 64. That is, my n is given to be 64 from a normal population with mean. So my mean is given to be mu and my variance is sigma square. Suppose that expected value and the variance of the sample mean is this. That means my expected value of what is given?
X lambda. For X
My
bar.
expected value of a sample mean, right?
X
What
bar.
is expected value and variance? Expected value? Expected value is given to be is given. Okay, so my expected value is given to be 40 and my variance is given to be 0.16. Find the value of mu plus 5 sigma, that is mu plus 5 sigma. Okay, now you guys remember that my expected value of a sample mean is coming out is equal to what? Mu only? Yes.
Yes, ma'am.
Yes,
Yes,
So
ma'am.
ma'am.
that means this mu is actually my 40. So I have the value of mu as 40. Now variance of x bar. What is variance of x bar?
Sigma square by n.
Sigma square by n. So the sigma square by n is actually what? 0.16. I have the value of n which is 64 equals to 0.16. So sigma square is basically 0.16 into 64. What is this value?
3.2.
It is coming out to be
Sorry, 10.22.
1.24.
10.24.
10.24. Now this is sigma square. So what is my sigma? 3.2, right? So I have the value of sigma, I have the mu. So just put this value. So this will be 40 plus 5 into 3.2, which is coming out to be
40 plus 16.
5.
Yes, ma'am.
Okay. Okay. Shall we move to the next question now?
Yes, ma'am.
Okay.
Yes, ma'am.
Now, suppose x1, x2, x3, x4 are IID following a Bernoulli distribution with 3 by 5 as the parameter. Define a random variable y, which is 2x1 plus 3x2 plus this. Find the expectation of y, variance of y, and the third question. Okay. I need the answer for the first question.
4.2. First answer.
4.2. Any other answers?
Five point zero four.
5.04.
8.4.
Yes, ma'am, 8.4.
Okay, 2 are for 8.4.
Same, ma'am. 8.4.
8.4. Any other answers? We got three different answers. Okay. Shall we solve? That's all? Or anyone solving it? By solving it,
8.4.
Yes, ma'am. You
8.4,
can please solve.
8.96, 8.4, two different answers. Now, expectation of y is basically what? Expectation of my 2x1 plus 3x2 plus 4x3 plus 5x4. Now, these are my ID samples, so I can say that 2 plus 3 plus 4 plus 5 common expectation of x, right? Yes,
Yes, ma'am.
yes. Okay. So this is what? 2, 3, 5, 5 plus 10, 14 into what is my expectation of x?
3 by 5.
Expectation of x is 3 by 5. So if you solve this, you should get what is the answer?
And
8.40. Okay.
shouldn't not reach writing.
Huh? Sorry. Once again. Okay. So this is my expectation of y. This thing is clear. Those who are getting answer 4.2, 5.04 and on, they are fine. They got their mistake.
Yes, ma'am.
Okay. Now, what is the variance of y?
Did 2.4.
Sorry.
Forty-seven point zero four.
47.04. Okay. Uh, any other?
Ma'am, 12.96.
Same 12.96, ma'am.
12.96.
Okay.
12.96, ma'am.
So we are just going to do the same thing only, which is 2 square plus 3 square plus 4 square plus 5 square into variance of x. So you just going to add these values into the variance of x, which is coming out to be, it is the Bernoulli,
Ma'am,
right?
6 by 25.
So 6 by 25. 6 by 25. What is this sum?
54.
54.
If you solve this, you should get 12.96. This thing is clear till here? Till variance all okay? Uh,
Yes.
Now comes the third part. Using Chebyshev's inequality, find an upper bound for expectation of this, where x bar is coming out to be this, is a sample mean. Enter the answer correct to two decimals. It should be probable. So we have been given probability of mod of x bar minus q is greater than 0.2. We need to find out the upper bound. That means it is greater than equal to sigma square by n delta square. This is the formula, right? Yes or no?
Yes,
Yes,
ma'am.
ma'am.
So can you just calculate and let me know the upper bound?
Yes, ma'am.
Ma'am, can you please scroll up?
So one answer is 0.69. Any other answers?
Ma'am, 1.5.
So that's 1.5. Can you guys confirm if you're getting 1.5?
Yes, ma'am, I'm getting 1.5.
1.5 only. So the answer is 1.5.
Yes, ma'am. According to the formula, the answer coming is 1.5, but it should be wrong, right?
Yeah, correct. That is what. If it's coming out to be 1.5, then it's wrong because the probability should be less than 1, only, right? It should not exceed 1. So maybe there is some correction. Okay, I'll just check it. Okay. So, but you guys got to know the concept, right? Yes? Yes or no?
Yes, ma'am.
Okay. And what I told in the theory part also, they will be just saying using the Chebyshev inequality. They won't be saying WLLI, right? They will be saying using the Chebyshev inequality, find the upper bound. Okay. Now, I'll just look into this question. I think there is some correction. Okay. Now, third question. A random sample of size 300 is collected from a population with a standard deviation of 20. Find a lower bound on the probability that the sample mean will be almost 4 away from the actual mean using WL.
So answer for previous question is 0.69, ma'am.
No,
One.
it's coming out to be 1.5.
Sigma square will be the previous whatever we find out, right? 12.9.
No. Sigma square, you have to find out. You find out y. Y, which is basically what? This is my y now. But what is my sigma square? This is the sigma square of x. And we don't know. We have to find out the variance of x, which is basically 0.
Okay.
Ma'am, could you solve that question?
Which one?
This Chebyshev inequality.
Distribution inequality.
Yes, ma'am.
This question is actually wrong, but I'll just let you know the concept. Okay.
Yes, ma'am. Yes.
So we have got this thing. They have given us this thing. We need to find out the upper bound. Okay. So this sigma square is actually what? The variance of x, correct? Let's suppose this is falling from x. So this is the variance of x, right? So first of all, the sigma square is basically 0.24, which is actually what? The variance of 3 by 5. So 3 by 5 into 2 by 5. Okay. Now this is n is what? What is my n here? N is 4 and my delta square is 0.2 whole square. So just put all these values here. Okay. Then you will get to know the upper bound.
Yes, ma'am.
Right? Okay. You solve this question. Question number 2. Did you guys solve it?
Give us a minute. We are still solving.
Sorry?
We are still solving.
Okay.
I'm 11 by 12.
11 by 12. So that will be what? 0. How
Zero
to
point
okay.
916.
Mhm. Okay.
Yes, ma'am. The same 11 by 12 formula.
Any other answer? Should I solve or anyone solving?
Yeah, ma'am, please. Because here the population standard deviation is given, right? Sigma square. So can we take that?
Ah, see, here the random sample of size 300 is collected. N is actually my 300 from a population with a standard deviation of 20. That means my sigma is given to be 20. Find a lower bound on the probability that my sample mean will be almost 4 away from the actual mean. Almost in the sense
Four.
this.
Delta is four, right?
Delta is this is my delta. So this is sigma square by n delta square, right?
Yeah.
Sorry, 1 minus sigma square. This is the thing. This is my lower bound.
Okay, okay.
Okay. So this will be what? 1 minus sigma square is 400 divided by n is 300 into delta will be 4 4 is 16. So if you solve this, you should get
Okay. Almost away means it is less than or equal to 4. We have to take when we are taking probability.
hmm. So this is my lower bound. Is this question clear to
Yes, ma'am.
everyone? The answer is 11 by 2. Somebody was getting 0.83. I don't know how. So you got the mistake. Who got 0.83 as the answer? Please give me a thumbs up or something. Okay, let's week. So that was all in week 7. Week 7, right? The main thing is this WLLN. Okay, and the which part? The sample thing. The main thing is they have just you just have to remember the sample for which we are calculating the expectation and the variance, and in the Chebyshev inequality, just remember that the sigma square is basically the variance of the population. Okay, just read the question carefully. Okay, don't do the same mistake here as you have done here. Okay,
Ma'am, what was wrong in this third part of the second
third
question?
part is the probability is coming out to be 1.5, which is not correct. It should be less than 1.
Why
It
is
should
that?
not exceed 1. The probability should be between 0 and 1. Na?
Yeah, that is true, but why is
Hmm.
it coming to be 1.5? Is there
Yeah,
a
maybe
problem in
there is.
the formulation of the question?
Yeah, in not in the formula, the values. I think it's wrong. Should I'll just look it. Okay, let's solve week 8. Now, let x be a random variable with PMF as this. Suppose x1, x2 are IID x. Define a random variable y, x1 plus x2. What will be the moment generating function of y? You need to calculate moment generating function of y.
Ma'am, generally it is not asked to centralize the x. Should we do it or not?
No, they are not asked to centralize. No, they are just given you y is my this. You need to calculate the MDF of y. That's it. If it is like if they are stated that you y is my centralized version of x, then only you have to do it. No?
Okay, ma'am.
Hmm. Is it done? What about others? Can you tell me what is the answer that you're getting?
1 by 4 e to the power 2 lambda, 1 by
Sorry?
6, 1 by 4
Uh,
e to the power 2 lambda,
uh,
1 by 16 e to the power 4 lambda,
1 by 6.
16 plus in between
It should
This
be
is the
plus
second
1
term.
by 16 e raised to
16
the power.
4 lambda
Hmm.
plus 1 by 4 e to the power 3 lambda.
That's it.
Yes, ma'am.
Okay. Everybody is getting this answer. No?
No, ma'am.
Okay. Okay. So let's solve this. So my y is basically
It should be all square, right, ma'am?
what square?
It should be squared, right?
It should be square.
Because y is equal to x1 plus x2, right?
It should be squared. So after squaring, you're getting this value. I don't know
No,
because
ma'am.
I don't know the
No,
answer.
ma'am.
That's why I'm asking you.
No, ma'am.
No, ma'am.
Okay, let's solve this. So basically, we need to calculate MGF of y. So this mx lambda whole square, correct? Because it's the addition. And what is my MGF of x? It is basically, anyone? 1 by 4 plus e raised to the power lambda into 1 by 2 plus e raised to the power 2 lambda into 1 by 4, correct?
Yes, ma'am.
So this should be my, everybody is getting this MGF?
Yes, ma'am.
So after this, you have to solve this. So this will be what? 1 by
Could you
4
please
into,
explain
hmm?
how you get mx lambda the value?
Okay. Okay, so this is my m by lambda. So this is what? Expectation of e raised to the power lambda into x1 plus x2. If you remember this thing, this one. What is
Yes,
my
ma'am.
MJ of this? This is mx lambda by whole square, correct?
Yeah.
Yeah, the same thing. This is clear, this explanation?
Yes, ma'am.
Okay.
I asked about how you get the value.
Which value? This value?
Yeah, the second line, 1
This
plus
thing,
1 by
huh?
4 plus e lambda into half.
Okay. So what is my MGF? MGF is basically my expectation of e raised to the power lambda x, right? And this can be
Yes, ma'am.
written as summation of x into probability of x. Sorry,
Yes, ma'am.
summation of e raised
No.
to the power lambda x.
Yeah.
So just in place of x, I'll just put the values of x, and in place of probability, for px, I'll just put the values of probabilities.
Okay, okay, got it.
Okay. So after this, you are just going to, this is a plus b plus c ka whole square. So this will be a square, 1 by 4, 1 by 16. This will be 116 raised to the power of 4 lambda plus 1 by 4 raised to the power.
Lambda, ma'am. Plus e raised to power 3 lambda by 4.
So this is the value of MJ of. Is it clear?
Yes, ma'am.
Yes. Okay. So this is how you calculate from the PMS. We have calculated the MGF of a different variable. Okay. Now next question. Okay. Let x1, x2, x36 are IID Bernoulli with parameter 0.5. Define a new random variable z, which is this. Using the central limit theorem, find the approximate value of probability of z less than equal to 20 marks.
No, 0.84.
0.84. Any other answers?
Sorry, ma'am.
Any other answers? Because
Like we use SLT theorem, right? And with that, we have to convert
PLT.
into normal. We have to convert to normal form, right?
Hmm.
Yes, ma'am. Ma'am, my answer is correct.
I could check it actually. I also don't know. I'll just solve it right now and then I'll get the answer. Two of you are getting 0.84, so maybe 0.84 is correct. What about others?
0.84, ma'am.
0.84.
So answer is 0.84 only. Okay, so let's solve this. So we have x1, x2, x36 are IID, calling a Bernoulli 0.5, and my z is coming out to be summation of all these values. Now we need to find out probability of z less than 21. So basically this is z. So if I need to send using the send, I need to approximate this. So basically what I will be doing, I will be approximating to a normal distribution, and if I have to do that, I will be subtracting it with the expectation of z and dividing it by the standard deviation of z. Is less than same here as well. Okay. Now this is, let's suppose this is my capital Z. So 21 minus what is expectation of Z?
18.
18.
Yes, ma'am. And standard is 3.
3.
Standard deviation is 3. So if you solve this, this is coming out to be 1.
Yes, ma'am.
This is coming out to be 1. So we have been given this value. So this is 0.84. So the answer is 0.84. Right? I think this question is clear. How to do the CLT thing, right? Okay.
Yes,
Shall we
ma'am.
move forward? Okay. Now we have in a manufacturing company, each machine produces 600 bottles daily. If a bottle is selected uniformly at random, then the probability that the bottle is of good quality is 60%. Suppose a sample of 20 bottles is selected from a quality inspection. Let a random variable x denote the total number of bottles that are of bad quality. Which of the following is true? Which option?
D.
D.
D. D. Yes, ma'am.
D. Any other?
C.
D.
No, C.
D. So there are C option, D option, and any other
Now here
option?
we have to calculate bad quality, right?
The question it is stating bad quality.
So okay. So then it's a C. Right.
Okay. Any other option? Any other options? Okay. So the first question is, suppose a sample of 20 bottles is selected. So here this is my N is selected for a quality inspection. Let a random variable X denote the total number of bottles that are of bad quality. Okay, so X is basically the total number of bottles that are of bad quality. Which of the following is true? So X is following binomial 600, comma 0.6, 20, comma 0.6, 20, comma 0.4, and okay. So many of them said C and many of them said D. Okay, can I know the answer for C?
Sorry, ma'am.
Can I know why option C is correct?
Ma'am, here N is 20,
Uh,
and here it is given 60 are good quality. So for bad quality, we minus 1 minus 0.6, so we get 0.4 P.
correct. Okay. And so the answer will be what? 20 points, 20 comma 0.4, right? Yes.
Yes,
So
ma'am.
here I'm having samples as n equals to 20 and my x is denoting the total number of bottles which are of bad quality. In the question, they have given that the bottles which are of good quality is 60%. So what will be the number of bottles who are of bad quality, which is 25, 40%? 100 minus 60, 40. So I've got the probability as well, which is this is my p. Okay, and my n is 20, so it will be following a binomial 20 comma 0.4. Fine? Yes or no?
Yes, ma'am.
Yes,
Okay.
ma'am.
Now, using the central limit theorem, find the approximate probability that the machine will produce more than 370 bottles that are of good quality on a particular day. Can I know the answer?
Ma'am, I find till Z value.
Just tell me that equation with Z thing.
Z greater than 0.83.
Greater than 0.83. Okay.
Ma'am, is there any shortcut way to find
Which one?
this after this process? Like Z greater than 0.83, you have to put in normal formula.
No, this Z that you are like this Z is actually what? This Z is actually if you are taking x as this x minus expectation of x minus standard deviation. This you are denoting as Z,
Yes, ma'am.
right?
Yes, ma'am.
Yeah, so this is my probability of z greater than 0.3. So you can take it as 1 minus probability of z less than equal to 0.83. Then you will be given this value, which is fz of 0.83. In the question, they will be giving you this value, and then you have to calculate the value.
Ma'am, FZ they given in the exam, right?
They will be giving, yeah, it will be given.
Ma'am, then it's okay. Okay.
Ma'am, I'm not able to understand how we are getting this answer. Can you please explain the logic?
Okay. So using the central limit theorem, find the approximate that the machine will produce more than 370 bottles that are of good quality on a particular day. So we need to find out probability that my x is greater than 370, right? So this will be, if I need to convert this into using central limit theorem, this will be x minus expectation of
Ma'am,
x
but X
divided by
denotes bad quality bottles, right?
x denote the total number of bottles that are of, okay, let's take it a different variable. Let's suppose this is y. So y is greater than. So I'm denoting y as the bottles that are of good quality. Okay, so this will be x minus expectation of x upon standard deviation of y minus expectation of y divided by standard deviation of y greater than 370. So minus expectation of y divided by standard deviation of y. So now this is, I'm just representing this as z minus 370 minus. What is my expectation of y?
And 360.
And
360, ma'am.
360.
How 360?
Okay. So basically, see, my x is following a binomial with 20 comma 0.4, right? My y will be following a binomial with 600 comma 0.6 because we are talking about good quality. This is about bad quality and this is good quality. Okay. So now y is following a binomial 600 comma 0.6. Then if I calculate the expected value of y, this would be n into p, which is 600 into 0.6, which is coming out to be 360. Yes.
Okay, ma'am, got it.
Divided by standard deviation. Variance of y will be npq, which is
Ma'am, it's
coming out to be 144. So standard deviation of y would be 12.
Well,
If you
12.
solve this, z is greater than either 0.83 only.
here we have used the fact that the sum of Bernoulli random variables will give us a binomial random variable, right?
Once again.
The sum of Bernoulli random variables will give us a binomial random variable
Ah,
for y.
ah.
Okay, ma'am, got it.
This question is clear. Can I move forward?
Yes, ma'am.
Can you please show the previous question so that I can take a screenshot?
I will be uploading this PDF. Don't worry.
Okay,
Okay.
ma'am. Yes, ma'am.
Now, last question. A fair coin is tossed 100 times. Let x1, x2, x100 represent the outcome of these tosses, where x1, xi equals to 1 represent head and xi equals to 0 represent tail. The random variable s is a summation of xi. Find the total number of heads in the 100 tosses. First answer. Okay, the answer is already there. But can you tell
Done.
me the reason why this is my answer?
Ma'am, could you zoom in little bit?
Okay.
Yes, ma'am.
Yes, ma'am, done.
Okay. Can you tell me why answer D is correct answer?
Ma'am, we calculate mean with NP. Here N is 100 and P for head is half 0.5. So here we calculate mean and variance and put in the normal form, which is coming
Hmm.
out to be
So
D.
basically what we are calculating here, we are calculating which of the following option is an acceptable approximate model as per the central limit theorem. Central limit theorem, that means we are approximating into a normal distribution with some mean and with some sigma square, correct?
Yes, ma'am.
Okay. Now, We know that my S is following a binomial distribution. Yes, with 100 comma 0.5 as the parameter.
Yes, ma'am.
Yes, ma'am.
Okay. So now, if I have to convert this S into a normal distribution, what I would be doing? I would be subtracting, like, if I have to convert this into normal distribution, the mean will be what? NP,
50.
and sigma
Yes,
square will be
ma'am.
what? NPQ. Yes.
Yes, ma'am.
Yes, ma'am.
So, so here we will be calculating what will be my NP. NP is 100 into 0.5, which is actually my 50, and N variance will be 100 into 0.5 into 0.5, which will be equal to 25, right? So that's why my S is following a normal distribution with 50 comma 25 when by using central limit theorem. Fine.
Yes,
Yes,
This
ma'am.
thing is clear. Okay. Now next thing is using the central limit theorem, find an approximate probability that the total number of S, that is S, lies between 48 and 52. Can you tell me the answer that, like, can you solve this and tell me
Ma'am,
if
in
you
the
are getting
first,
this answer?
ma'am, in the first part, A option is also right, right?
No. How is AM?
Oh, sorry. It is as per the central theorem.
Uh,
Ma'am, minus point 4 to like a point 4.
huh?
Its
Okay, you are
range
just
is
telling me that thing. Okay,
lower
what is
bound
the
and upper bound. Minus point 4 to plus point 4. Point 4, ma'am. 0.4. Minus 0.4 also.
okay, this one. Everybody is getting this thing?
Yes, ma'am.
Yeah?
Yes, ma'am.
Okay. So what is this? We need to find out probability that my X is between 48 and 52. Right? So this will be what? 48 minus my expected value is 50 divided my standard deviation is 5 is 52 minus 50 by 5. So this is probability of minus 2 by 5, 2 by 5. This is actually probability. It is going from minus 0.4 to 0.4. Sorry, this will be there. Okay. So this is like 2 times of probability that my Z is less than 0.4. So you will be given this value. You have to calculate it. This is like Fz of 0.4. Okay. So this was the question.
Ma'am,
Ma'am,
I have
can
a
you
doubt.
explain the last,
Huh?
can you explain the last equation?
This one.
No, ma'am, below that.
This thing. This is just we are solving this equation that my Z is going between. Just a second. 2Z less than, okay, minus 1. So this is probability that my, let's suppose this is minus 2. So I can write this as probability of Okay, so this will be z is less than a. Okay, you just have to remember this one. So the probability that my if like minus a to a is equal to 2 into probability of z less than a minus 1.
Understood.
Okay, so that was all in week 7 and week 8. I hope the concept and everything is clear.
Now I have a doubt in 8.4 last activity, last question.
8.4.
Last question.
Okay, 8.4. Last question.
Yes, ma'am.
Mhm. Thank you for the reading. Okay, so this is basically this I can write this as variance of x1 square plus variance of x2 square plus variance of x3 square plus variance of x4 square. Right? So this will be 4 into variance of x square. So first of all, we need to find the variance of x square. So variance of x square will be what? Expectation of x raised to the power 4 minus expectation of x square whole square. Then we need to find out expectation of x square first. Okay, I'll just give you the hint and you have to solve it. Okay, is it
Yes,
fine?
ma'am.
Huh.
Yes,
So
ma'am.
okay. So if you see here, I need to find out variance of x1 square plus x2 does this. Okay. So now as they are IID, so I can write this as equal to the sum of their individual variances. Yes. Can
Ma'am,
I
here
write
I
it
am
in this way?
confused with X4. EX4. I'm not able to find that.
That is it. So this is actually 4 into variance of x square, correct? This till here it's fine.
Yes,
Till
ma'am.
this part is fine. Okay. Now we need to find out the variance of x square. Now if you remember, my variance of x is basically what? Expectation of x square minus expectation of x whole square. Yes.
Yes, ma'am.
So in place of x, I'm just putting it x square. So this will be what? Expectation of x raised to the power 4, 2 to the 4
Yes,
minus
yes,
expectation of x square whole square, right?
yes, ma'am.
So now first of all, you need to find out this thing. My expectation of x square will be what? Variance of x plus expectation of x whole square.
Yes, ma'am.
So you have this value from the sample, which is normal 0, 4. So you put this value, you will get this value. After getting this value, just put it here.
Okay.
Okay. And similarly, you can calculate this value, expectation of x4.
Okay, ma'am.
Okay. Then just put all these values, you will calculate this variance of x raised to the power.
Okay, ma'am. Okay. Thank you, ma'am. Thank you so much.
Anything else? So that was all in week 7 to 8. I hope week 7 and 8 is clear to everyone. The main thing is you just have to remember all the formulas, how you write the MGF part, okay, and then the CLT and WLSS. And you just need to
Graph
know
will
what.
not come.
Huh?
And the distribution graph will not come in exam.
No, no, no.
Okay, ma'am.
Hmm. All of these things, just remember the concept and everything and the formulas. Just remember what is your lower bound, what is your upper bound, the formulas and everything, and then it will be fine. From the MGF, how do you calculate the BMF and everything? You just have to remember all of that thing. Okay?
Yes, ma'am.
Ma'am, ma'am, can you please present the question you were just presenting right now?
The PDF. The
Yes, ma'am, the question that student just asked.
one. Am I representing? This one?
Yes, ma'am. Can we not write e of x square as e of x into e of x because they are independent?
E of x square.
Yes, ma'am. In the variance of x square formula, the first term can be written as e of x raised to power 4 because x is independent. So because they are independent and they are uncorrelated pairwise.
It will be x. Mm. But we are just talking about the x square, right? My x1, x2, x3 are IID samples, not the x. Getting my point? We are talking about expectation of x square. So my x is getting squared, not my samples. If it had been like x1 into x2, then you could have written as uh, x square like that.
Oh, so it's another random variable x square x to the power 4.
Ha, ha, ha.
Okay, ma'am, got it. Thank you, ma'am.
So that's it then. Okay. So again the meet. Everything is okay. Week 7 and week 8, all clear?
Yes, ma'am.
Okay.
Thank you, ma'am.
Yes, ma'am.
Okay.
Thank you, ma'am.
Thank you, everyone. Have a great time. All the best for the exam. Okay. Just remember the concept and everything will be good. Okay. Just stay calm. Okay.
Thank you, ma'am.
Okay.
Thank
Bye,
you, ma'am.
everyone. Have a great night. Bye bye.
Bye,
Bye.
ma'am. Thank you, ma'am.